Hi, math students. It's Mr. Rich here. I'm your math coach for all high school math, from algebra to calculus and SAT and ACT math and everything that's in between. And today I want to work the AP Precalc 2025 FRQ number 2. And here is what it said. A musician released a new song on a streaming service. A streaming service is an online entertainment source that allows users to play music on their computers and mobile devices. I'm sure that you all know that. Several months later, the musician began using an app at time t equals 0 that counts the total number of plays for the song since its release. A play is a single stream of the song on the streaming service. The table gives the total number of plays in thousands for selected times t months after the musician began using the app. At t equals 0, the total number of plays was 25,000. At t equals 2, the total number of plays was 30,000. At t equals 4, it was 34,000. So there you go. So we've got the information in that table. Then it says here that the total number of plays in thousands for the song since its release can be modeled by the function d, given d of t is equal to at squared plus bt plus c, where d of t is the total number of plays in thousands, and t is in the number of months. So the first question, part A, Roman numeral 1, says, use the given data to write 3 equations that can be used to find the values for the constants a, b, and c in the expression for d of t. So what we would do here is we're going to use 2 of these points. We're going to use the first one, 0, 25, and we're going to plug that in, right? So we're going to plug this in and say that there were thousands of releases, or plays rather, at time t equals 0 when he started using this app. So that would mean that we have a times 0 squared plus b times 0 plus c. So that's one of the equations, which obviously is going to give us the value for c. The second equation is going to be this. 30 is equal to a times 2 squared plus b times 2 plus c, using the second ordered pair. And then using the third ordered pair, after 4 months of using the app, the total plays was 34,000. And those are our 3 equations that they wanted us to write. And there you go. So that is our answer for Roman numeral 1. Roman numeral 2 says find the values of a, b, and c as decimal approximations. Here were those 3 equations that we answered in the previous part of this problem. And what we can do is we can say, well, we know that c is equal to 25 based on the first equation, which then gives me these 2 equations when we substitute that in. That would be 30 would be equal to 4a plus 2b plus 25, and 34 is equal to 16a plus 4b is equal to 25. Now I'm going to go and solve this equation by doing it in Desmos, actually. I'm going to use x for a and y for b. And there are my 2 equations entered into Desmos, and we will zoom in and see where the intersection point happens to be. And there is the intersection point. So A is a negative 0.125 and B is 2.75. So we can write that down. We now know that A is negative 0.125 and B happens to be 2.75. And that is our answer. So we have answered the question completely. A, B, and C. Find the values as decimal approximations. That's going to be it. Now, just as a point of interest, could you have used Desmos to get this, or to at least check your answer? I believe so. So here's what I'm going to do. I'm going to go ahead and put a table into Desmos here and put each of these ordered pairs in. And let's zoom in just a tad here to make this look a little bit bigger. And now that I've got those 3 ordered pairs in, I'm going to go ahead and run a quadratic regression on this. And sure enough, that confirms that we have the right answer right there. I would have felt more comfortable going ahead and at least showing my work to this point before I would do this. And I'm just using Desmos there, spending about 30 seconds to check my answer. So let's move on to the next. The next part says that use the given data to find the average rate of change of the total number of plays for the song in thousands per month from 0 to 4 months. Express your answer as a decimal approximation. Show the computations that lead to your answer. So what we'll do here is we will write down how to find an average rate of change between 0 and 4 months. So they want us to use the given data. So that means that we would use D. Well, let's see. Let's just write the actual expression. So we're going to put our 34 minus 25. We're taking the difference in the plays at those 2 months, and then we will do 4 minus 0. And I think, though, one of the things that we have to be careful of here is that it's specifically saying the average rate of change of the total number of plays for the song between 0 and 4. And yeah, so that's fine. So the average rate of change is going to be the 34 minus 25. And so that means that there were 9 thousands of plays divided by 4, which means the answer here would be 2.25. And that would be thousands of plays per month. Okay, and they wanted it as a decimal approximation, and that is how we're going to do that. Okay, that was average rate of change. Roman numeral 2 of Part B says use the average rate of change that you found in Part B1 to estimate the total number of plays for the song in thousands for 1.5 months. Show the work that leads to your answer. So what they want us to use here is the point slope form. Now, those of you that are moving on to AP Calculus, you'll be using the point slope form quite a bit when we make equations of tangent lines. Here, we are really making an equation of a secant line because I'm going to use these 2 points, the line that passes through those 2 points. We already determined what its slope was, right? The slope of that line that passed between those 2 points is 2.25. So we're going to use that for M, and then we're going to plug in one of the 2 points that we know is on that secant line, and I'm going to use the 0, 25. So this would be Y minus 25 is equal to 2.25 times X minus 0. Okay, and what I'm doing here is I'm putting in for my X1 and Y1 one of the 2 ordered pairs, and I'm putting in the 0, 25. I will go ahead and move that 25 to the other side by adding it over. So we have 2.25x plus 25. Now that becomes then an equation that we could use to make estimates for values that are between 0 and 4, and we're going to use that for 1.5. For t equals 1.5. Now keep in mind, our x here is t and our y is the plays in a month, but we're going to say that by plugging in 1.5, we're going to get 2.25 times 1.5 plus 25. So we will come over here to Desmos and put that, and we get 28.375. And that is thousands of plays. Okay, that's our approximation. And we've shown our work by making the equation of the secant line that passes between those 2 points, and then use that secant line equation to make an estimate when t is equal to 1.5. And that's going to be our answer. Let's move on to Roman numeral 3 of Part B. It says, let A of t represent the estimate of the total number of plays for the song in thousands using the average rate of change for Part B1. For A 1.5 found in Part B2, it can be shown that A of 1.5 is less than D of 1.5. Explain why, in general, A of t is less than D of t for all t 0 to 4. Your explanation should include a reference to the graph of D and a relationship to A of t. So, what we're really thinking about here, students, is that they want you to understand that the equation that we came up with, where we found those coefficients A, B, and C, going back all the way here, right? That was the equation right here, D of t. And we'll go ahead and write that down because I want to make a point about it, right? This is how you would be thinking about this. You would say, well, I do know that D of t would be equal to negative 0.125 x squared plus 2.75 x plus 25, which is a quadratic equation with a negative leading coefficient. So that means that whatever this looks like, and by the way, the nice thing about checking this equation over here is I can go ahead and hit this button right here, blow that equation into a separate graphable, if that's a word, equation, and we're actually looking here at that parabola that's opening downward. Now, what is the equation? Now, if you're not sure what's going on here, one of the things you could do is even graph the equation that we had created up here, right? The linear equation, the secant line. So let's go ahead and do that just so that we can see what is going on. See, what we did is we graphed that purple line, or we created that purple line by using this point here at 0.25 and this point at 4,34, and there's the secant line. Now, what we do know is that between 0 and 4, any estimate that I would use or that I would generate using that purple line, that secant line, has to be an underestimate for the value that the quadratic would have provided to me, because of the fact that this green line, this parabola, is concave down, and therefore I would know that the secant line is below it. All right, so even if I didn't have a graphing tool available, what they want you to know is that what you just did was to create a quadratic equation in the first part of the equation, or the first part of this problem, I should say, and then you found a secant line that would have been below the quadratic because the quadratic was concave down. All right, so that's going to be what our answer is. And actually, so here's where we're writing this. So in general, why does the average rate of change quantity have to always be lower than d of t? It would have to be an answer that looks something like this. It would look like this. A of t has to be less than d of t for all values of t between 0 and 4, because d of t is concave down. Thus, a of t, the secant line from 0 to 4, would be lower than d of t. And I could tack on there, any estimate obtained using a of t would have to therefore be lower than the value that d of t would provide for the total number of plays. All right, let's move on. Part C, we're almost there. This one says that the quadratic function model D, which is our parabola over here that we generated using our regression, has exactly one absolute minimum or one absolute maximum. Well, of course, it has an absolute maximum because of that negative leading coefficient and it being a quadratic. That minimum or maximum can be used to determine a domain restriction for D. Based on the context of the problem, explain how that minimum or maximum can be used to determine a boundary for the domain of D. It's really a good question that is forced to make you think of what the function really does mean. All right, what does the function, that in fact, we're really referring to the function being these values here, right? These are not plays in the month. This does not mean that there were 25,000 plays in the first month or that there were 30,000 plays during the second month. This is what we would call a cumulative total. It's the number of plays since its release. So really, in between t equals 0 and t equals 2, there were 5,000 plays because the total plays went up from 25 to 30. And then between months 2 and 4, the number of plays was about 4,000 because of the difference being that the 34 is the accumulated number of plays all the way up to that point in time. So therefore, it is impossible for these total number of plays to start decreasing because of the fact that it is a cumulative number, right? You can't go down on an accumulation because you can't have negative plays. That would cause the numbers to go down. So therefore, this function really is only valid up to the point where you would get at the very top here at t equals 11. Now, they're not really asking us what is the restriction, I don't believe. It just wants to know why could that value be used for a domain restriction. So I would phrase it something along these lines. So I would phrase it like this: because the function is the accumulated number of plays as a function of time, it's not possible for the function to ever decrease. It can only increase or stay the same if there are no more plays. It could never go down. The value of t at which there is a relative maximum value of this d of t function would represent the upper limit of the domain of d of t. So even if everybody stopped playing this musician's song, what would happen is it would stop at whatever the ending number of plays was at that point in time. It could stop and say at the next month it was 34,000 and 34,000. It could never go down, right? So anyways, so that's what they were wanting you to consider. That's why they said here, based on the context of the problem and what this means, right? That doesn't mean songs in the month. It means the total accumulated number. All right, students, I hope that was helpful to you. If this video did help you out, hit the subscribe button. I do post videos every month. And check out my Twitter account and my YouTube channel, which are going to be linked below. All right, everybody, have a great day. I'll see you in the next